Dear students, welcome to the module 25 of the MOOC course on Solid and Hazardous Waste Management. Now, today in this module, we will be discussing about the thermal treatment of waste with special emphasis on pyrolysis and gasification. Now, solid waste is any unwanted material that is just disposed of into an open environment without any protection. Now, this creates a lot of environmental hazards and health hazards. To avoid these problems, the waste that is generated from different sectors like the residential sector, commercial sector, institutional sector or agriculture sector, they have to be treated and then disposed of into a safe environment. Now, the treatment methods are of different types. One is thermal treatment, the other one is biological treatment. Now, under thermal treatment, the waste is generally subjected to a very high temperature and destructed into simpler compounds like carbon dioxide, methane, water vapor and other oxides of sulfur and nitrogen. Among the thermal treatment, advanced thermal treatment processes or technologies are designed with the purpose to destruct the waste at very high temperature in the presence or absence of oxygen, resulting in the production of certain end products that can be used to convert into energy or other chemical feedstocks. So, pyrolysis and gasification are one such advanced thermal treatment process where the waste can be subjected to a very high temperature and it can result in certain end products which can be used to convert into energy and other chemical feedstocks. With this introduction, now let us get into the learning objectives of this module. The learning objectives of this module include: first, we will understand the concept of advanced thermal treatment technologies. Then, we will study in detail about pyrolysis and the gasification process. We will also look into the various products that are generated from them during solid waste thermal degradation. Then, we will understand the various mechanisms of pyrolysis and gasification process. Then, we will also study about the different types of pyrolysis and gasification process which are available and various reactors that are used to perform the pyrolysis and gasification process. Finally, we will understand the different merits and demerits of the pyrolysis and the gasification process. Now, as I told you earlier, advanced thermal treatment technologies are waste treatment technologies that uses a very high temperature to degrade or destruct the waste. They are specifically designed in a way to recover energy in the form of heat or electricity and other end products which can be used as a chemical feedstock. The main purpose is to reduce the impact of residual waste on the environment. Now, pyrolysis and gasification are examples of these advanced thermal treatment technologies. Now, as I told you earlier, pyrolysis is a process where the waste is thermally destructed in the absence of oxygen at a temperature of 300 to 850 degrees Celsius. Now, gasification, it is done in the limited supply of oxygen at a temperature of 900 to 1400 degrees Celsius. Now, the pyrolysis results in the production of three compounds: one solid, liquid and gases. Now, solid char, liquid oil and the gases like carbon monoxide and gases like hydrogen and carbon dioxide. Now, likewise, the process of gasification results in the production of syngas, which is carbon monoxide and hydrogen, and tar and other fertilizer value products. Now, let us discuss about pyrolysis in detail. Now, in pyrolysis, the organic waste is thermally destructed in the absence of oxygen. Now, oxygen is one thing which determines or differentiates pyrolysis from other process like combustion and gasification. Combustion, again, it is done in the presence of oxygen. Gasification is done in the limited supply of oxygen and pyrolysis is done in the absence of oxygen. Now, the temperature range, again, it varies from 400 to 800 degrees Celsius. This temperature is comparatively lower than incineration, and during the pyrolysis process, since they are operated under a low temperature, this results in the emission of less air pollutant. It also produces products like char, a solid product, oil, a liquid product, and certain combustible gases. Now, pyrolysis is a flexible process and they have an ability to produce solid, liquid and gaseous products, and the level or the quantity of the solid, liquid and gaseous products depends upon the temperature and the heating rate. It transforms low energy density waste to 1. Biofuels of high energy density and high value chemicals. The end products that are obtained at the end of pyrolysis process are explored for fuel applications, as a chemical feedstock and for other energy extraction process. The mechanism involved is very simple. Here the complex materials like your paper, plastic, metal, glass, cardboard, leaf litter and hazardous and other biodegradable and hazardous chemicals are heated at a very high temperature, and at this temperature the complex polymeric organic molecules like cellulose, hemicellulose and lignin, they break down and get converted into short chain molecules. Now, further exposure to heat breaks the short chain molecules into oils and other gases. Now, let us discuss about what are the different products that are produced during pyrolysis and at what condition that they are produced and where it is used and what are its applications and significance. Char is a solid end product of pyrolysis. The char production can be maximized at low temperature and a slow heating rate. The percentage of char production depends upon the pyrolysis process condition. Moderate heating in the range of 20 to 100 degrees Celsius per minute at a maximum temperature of 600 degrees Celsius results in the equal proportion of oil, char and gas. Now, this method is generally referred as conventional or slow pyrolysis. The solid char that is produced from the slow pyrolysis can be used as a charcoal. Now, the char formation is generally reduced in flash pyrolysis process. Now, examples of products from which char is produced during the pyrolysis process is like the pyrolysis of tire results in 49.5% of char production with an ash content of 10%. Municipal solid waste produces 35% of char with a high ash content of up to 37%. Likewise, the pyrolysis of wood results in 23% of char production. Now, char can be used as a medium grade solid fuel. It has a good calorific value. Some examples are the char that is generated from the municipal solid waste contains around 19 megajoule per kg calorific value. Likewise, tire shows or contains a calorific value of 29 megajoules per kg and wood contains 33 megajoules per kg. Now, generally the value of char in fuel production is minimized due to the ash content that is present in the product at the end of pyrolysis. Higher the ash content, lower will be the fuel value. So, generally what you have to do is you can do de-ashing before using it for the fuel purpose. The next product that is produced during the pyrolysis process is oil. The oil generated from the pyrolysis process contains a high energy density per unit weight. They can be used as a fuel with certain modification. Generally what do they do is they combine or mix them with petroleum refinery stock and upgrade the quality using certain catalyst. The calorific value of oil generated from these municipal solid waste ranges from 25 megajoules to 40 megajoules per kg. Now, the composition of oil is very complex and contains a wide variety of chemicals ranging from your organic acids, phenols, alcohols, aldehydes, ketones, furans, etc. Maximum amount of oil production can be obtained by flash pyrolysis. If you talk about char, slow pyrolysis results in maximum char production and flash pyrolysis results in reduced char production. So, here maximum oil production can be obtained by flash pyrolysis process. Now, depending upon the feedstock that is used in the pyrolysis process, they can be categorized. I mean the oil produced can be categorized as a true oil, oil aqueous phase, separated oil and aqueous phase. Now, let us see what are the applications of this oil. Now, the oil that is derived from the pyrolysis of municipal solid waste cannot be used directly as a fuel because of the presence of solid char particles, viscosity and acidity. So, you have to refine them and then use it. So, the pyrolysis oil is generally used as a chemical feedstock. Chemical feedstock means it acts like a raw material for the production of any other products. Now, the compounds like methyl phenol, methoxyphenol furfural, methoxypropenyl phenol are produced during wood pyrolysis. They can be used in food, paint and pharmaceutical industry. Likewise, the oil that is generated during the tire pyrolysis contains DL-limonene. It can be used as a solvent and adhesives in certain industries. They also replace chlorofluorocarbon and can be used as a cleaning agent for electronic circuit boards. Benzene, toluene, xylene and styrene that are produced can be used in chemical and pharmaceutical industry. Likewise, the waxy oil that is generated during mixed pyrolysis can be used in catalyst cracking to produce gasoline. The third product that is produced during the pyrolysis process is gases. Now, the gas generated during pyrolysis process is composed of hydrogen, carbon monoxide, carbon dioxide, methane and certain hydrocarbon gases are also produced. High levels of carbon dioxide and carbon monoxide are due to the presence of cellulose, hemicellulose and lignin in the waste material. Now, high levels of hydrogen, methane and other hydrocarbon gases are formed during the pyrolysis of tire and mixed plastics. These gases generally have medium to high calorific value. Now, conventional pyrolysis of municipal solid waste produces gas with calorific value of 18 megajoule per meter cube, unlike your wood which produces 16 megajoule per meter cube of gas. High heating value and temperature breaks down the pyrolysis oil to gas. So, a maximum calorific value of 40 megajoule per meter cube is observed in gas produced during tire pyrolysis. Higher gas yields are generally found in pyrolysis process where the products are kept or exposed to a hot zone for a long period of time. Now, the gas yield, if you see, they are higher even at temperatures above 750 degrees Celsius. Now, when your feedstock is original, then the gas yield can increase up to 70%. Now, let us discuss about the various types of pyrolysis process. As I told you earlier, you have slow pyrolysis, flash pyrolysis, vacuum pyrolysis. Now, let us discuss about the different types of pyrolysis process. Now, first one is slow pyrolysis. Now, slow pyrolysis is also referred to as conventional pyrolysis process. In this type of pyrolysis, heating is done at a very slow pace and low temperature, and it results in the production of maximum amount of char. When heating is done at a temperature of 600 degrees Celsius and at a heating rate of 20 degrees Celsius to 100 degrees Celsius per minute, the oil, char and gas production becomes equal. This I have already told you earlier. So, under a slow pyrolysis process, you can achieve equal amount of oil, char and gas. Since it involves a very slow heating rate and slow removal of products from the pyrolysis unit, the formation of secondary reactions are more frequent. The next type of pyrolysis process is your fast or flash pyrolysis. Here, it involves a temperature below 650 degrees Celsius, but a very high heating rate of about 100 to 1000 degrees Celsius per second. The process results in a maximum liquid yield of 70% with a minimum amount of char and gas. The gas production is minimized due to rapid quenching of liquid that is generated during the pyrolysis process. Also, high reaction rate minimizes the char formation. Wood and tire are examples of waste that can be pyrolyzed through flash pyrolysis process. The next type is your vacuum pyrolysis. Vacuum pyrolysis is generally done or conducted at a low pressure of about 5 kilopascals. Short residence time and low decomposition temperature generally avoids or reduces the frequency of secondary reaction formation. Vacuum pyrolysis can be done for different types of waste like your household waste, wood, plastic, tire, circuit boards and so on. This type of pyrolysis, however, is not common among other types. Now, let us discuss about the different types of pyrolysis reactors. The first type of pyrolysis reactor, it is a fixed bed reactor. It is one of the simple reactor, the design is very simple and you can construct it very easily. The reactor is generally made up of stainless steel, which is heated externally through an electric furnace, and inside you flush in nitrogen or argon gas to make it or maintain inert condition, because pyrolysis works under absence of oxygen condition. Now, the waste is placed at the bottom and then it is subjected to heat. Fixed bed reactors work under the principle of slow pyrolysis, where the heating is done at a very slow pace. The drawbacks of the fixed bed reactor are: 1. Lack of uniform heating due to non-movement of waste within the reactor. There is absolutely no mixing. So, you cannot expect a uniform distribution of heat throughout the pyrolysis unit. Fixed bed reactors can be used for large scale application, provided if you provide certain measures for uniform distribution of heat throughout the unit through certain pipelines. Now, the gases that are generated during the process can be collected every day, while the char can be collected at the end of the process. The second type of reactor is your batch reactor. Now, in this type of reactor, waste is just loaded into the unit, sealed and operated. Neither you add any reactant nor you remove any product during the operation of batch reactors. Here, high conversion rate is observed because the reactor is closed and sealed. However, in semi-batch reactors, if you see, addition of reactants and removal of products is generally allowed. The end pyrolysis product is not uniform for every batch. For example, if you operate the unit in the first batch, you can receive certain products, but this products or the quantity or the composition of product will not be same for the next batch which you are operating in the batch reactor. So, that becomes a major disadvantage. The third type of reactor is your fluidized bed reactor. Here, the waste material is fluidized within the reactor. Fluidized means it is just bubbled. The waste material keeps moving up and down, bubbling inside the reactor. So, fluidization generally results in good mixing and good and proper distribution of heat within the waste mixture. The characteristic feature of the fluidized bed reactor is: 1. High heating rate, it retains the heat for a long period of time, and also it distributes the heat uniformly throughout the unit. Now, it again works under the principle of flash pyrolysis, and as a result in the generation of maximum amount of oil, that is around 70%. Municipal solid waste, especially the polymers, plastics, are pyrolyzed in the fluidized bed reactors. Polymer generally possess certain low thermal conductivity and high viscosity as their characteristic. So, fluidized bed reactor will be optimum for those. High heating efficiency and high heat distribution in fluidized bed reactors generally facilitate the cracking of these polymers. But these reactors generally suffer from two main problems. One, the char separation from the reactor is very difficult, and better fluidization is achieved only if the particle size is of smaller size. So, the waste requires certain pre-treatment before being subjected to a fluidized bed reactor. So, what you have to do is, after collection, the material should be sorted, dried, crushed or shred into small pieces and then loaded into the reactor for the pyrolysis process. Plastics and paper can be shredded or cut into a size of 5 mm, and biomass can be reduced to a size of 1 centimeter. Now, the fluidized bed reactors are very difficult to scale up, and hence they have a limited application only in the laboratories. Now, let us look into the advantages of pyrolysis process. Now, pyrolysis process is used for degrading biodegradable waste and plastics using high temperature. Now, here you can recover energy in the form of heat or electricity. Now, when compared to mass burning, energy and other value added products are recovered by the advanced thermal treatment process like pyrolysis. Now, high temperature that is involved in pyrolysis generally will kill all the pathogens and harmful organisms present in the solid waste. Also, it will reduce the water content of your final product. The gas that is produced during the thermal degradation process can be used as a fuel. Now, it minimizes, if you use them as a fuel, it will minimize the load on the use of external fuel if the producer fuel is used for pyrolysis. Then the biochar, the char that is produced during the pyrolysis process can be used as a soil amendment or as a activated carbon. Now, biochar is reported to sequester carbon and increase the fertility of soil. This again becomes an added advantage of the pyrolysis process. The bio oil that is produced can be combusted either directly in the boilers and engines. Also, this process degrades even the complex pollutants into simpler ones. Then it favors recycling of mixed plastics and soil plastics which cannot be taken for recycling process. This you can achieve in the pyrolysis process. Okay? Which means like only plastics which have certain strength or thickness can be recycled. So, other plastics like your poly bags or soiled plastics which is used in agricultural plastic, mulch, silage or greenhouse films, they can be recovered or destroyed in the pyrolysis unit. Now, pyrolysis unit again minimizes the volume of waste and the amount of residual waste that is sent to the landfill is very, very less. The pyrolysis plants are very flexible because they are modular in nature and you can fix them at any point and perform the process. Even you can fix it at the source of generation or in the transfer station or even at the disposal site. The number of pyrolysis unit also can be added or reduced according to the requirement of a society or a community. Also, these units are very easy to be built. Moreover, pyrolysis units, since they work under very low temperature, the air pollution emission levels are very less, unlike your incineration process. Now, let us discuss about the disadvantages of the pyrolysis process. Now, pyrolysis can be used only for residual waste because it will undermine the advantages of recycling and the composting process. Second, feedstock of pyrolysis generally needs a pre-treatment or pre-processing before being subjected to the pyrolysis process. High capital and operational cost. Pyrolysis process involves high capital and operation cost because they are very energy intensive because it involves a very high temperature. Then it requires skilled operators for operating the unit. Now, also though it emits less air pollution control devices needs to be installed to the pyrolysis unit. The ash that is generated during the thermal degradation may contain certain heavy metals and would require safe disposal. With this, let us look into the process description of the gasification process. Now, gasification is a process by which solid or liquid waste material are converted by the action of heat into a gaseous material, ash and tar in the limited supply of oxygen. It is a unique process in which the carbon that is present in the municipal solid waste is converted into an energy without burning them. The gases that are generated during the process is carbon monoxide and hydrogen. They are generally termed as a syngas. Other gases like carbon dioxide and methane are also produced. Gasification is done at a temperature of 800 to 1400 degrees Celsius and air, pure oxygen and steam can be used as an agent for performing the gasification process. According to the use of supplementing agent for burning the waste, the calorific value of the gas also keeps changing from a low calorific value of 4 megajoules per meter cube to 20 megajoules per meter cube. That is, when air is used, the calorific value is low, and when steam is used, the calorific value is as high as 20 megajoules per meter cube. The calorific value of the gases that are produced during the gasification process is comparatively low when you compare with the natural gas, which contains a calorific value of 37 megajoules per meter cube. Now, let us discuss about the mechanism that is involved in the gasification process. During the limited supply of oxygen, carbon molecules that are present in the waste will be oxidized into carbon monoxide. Now, the carbon monoxide can also be formed the reduction of carbon dioxide and water that is present in the solid carbon surface. So, gasification is always preceded by pyrolysis, and hence char like organic material can be used as a feed for gasification process. What I mean to say is pyrolysis can be done, the char that is produced in the pyrolysis process can be further subjected to gasification process to result in the production of syngas. Now, gases generally interact with the solid char interface to extract carbon off from the surface into gases such as methane, carbon monoxide and carbon dioxide. And gaseous water can interact with the char surface to be reduced into gaseous hydrogen. So, the carbon combines with half a molecule of oxygen to provide carbon monoxide, and I told you carbon monoxide can also be formed by from carbon dioxide. So, the carbon combines with carbon dioxide to form 2 molecules of carbon monoxide. Then from the gaseous water molecule, I mean the water vapor can again combine with carbon and produce carbon monoxide and H2 gas. When they are put together, they are called as syngas. Now, let us discuss about the different types of gasification process. Now, depending upon the agent that is used for performing gasification, like your air, oxygen, steam or hydrogen, they are classified into different types. One is air gasification, 2 oxygen gasification, 3 steam gasification, 4 gasification with hydrogen, 5 thermal depolymerization, and the last one is plasma gasification. Now, air gasification is a process where air is used for gasifying the waste material, and the temperature requirement is 800 to 1100 degrees Celsius. Now, this in general produces a gas or fuel of low calorific value in the range of 4 to 6 megajoules per meter cube. The moisture present in the air produces hydrogen. In addition to other gases, nitrogen also occurs as one of the major component in addition to carbon monoxide, carbon dioxide and methane. Nitrogen generally reduces the calorific value of the gas. The next type of gasification process is your oxygen gasification. Here pure oxygen is used for gasifying the solid waste. The temperature is relatively high in this particular gasification process, and it is around 1000 to 1400 degrees Celsius. The calorific value of the fuel that is produced is medium and is around 10 to 15 megajoules per meter cube. Steam gasification is usually used as a supplement to oxygen to control the temperature. It is generally an endothermic process, and it is operated at a temperature of 700 to 900 degrees Celsius. Now, steam gasification is again operated at a pressure of 20 bar and a temperature of 700 to 900 degrees Celsius. Under this pressure, the steam gasification becomes a exothermic process. Now, the calorific value of fuel that is produced during the steam gasification process is around 15 to 20 megajoules per meter cube. However, under high pressure, certain additional reactions also occur. The equations provided here depicts the steam gasification process. Carbon combines with water to form carbon monoxide and hydrogen. It also produces carbon dioxide and hydrogen. Likewise, carbon monoxide once again combines with water to form carbon dioxide and hydrogen. Carbon also combines with hydrogen to form methane. Under high pressure conditions, I told you certain additional reactions also occur, like carbon monoxide combines with hydrogen to form methane and water, and carbon dioxide combines with hydrogen to form methane and water. So, methane is another additional product that is produced during the steam gasification process. The next type of gasification is gasification with hydrogen. Now, here pure hydrogen is used for gasifying the waste material, and it is also called as hydrogasification. Now, it is considered as a better alternative than your gas gasification system. It can crack tar in the gasification vessel, and it can result in the formation of methane rich gas. Methane can be later converted into hydrogen or methanol according to your requirement. The next type is your thermal depolymerization, which involves a very high energy microwave to burn the waste in under nitrogen atmosphere or inert atmosphere. The waste absorbs the microwave and increases the internal temperature and the energy of organic material. This results in thermal decomposition of waste. Again, as I told you earlier, nitrogen inhibits or reduces the calorific value of the fuel. Thermal depolymerization can also be done under temperature of 150 to 350 degree Celsius. The last type of gasification process is your plasma gasification, which is carried at a very high temperature of 5500 degrees Celsius. Plasma is nothing but an ionized gas formed when an electric discharge is passed through a gas. In plasma, the electrical energy is converted into intense heat, that is thermal energy, and at that temperature plasma destroys even the hazardous waste. The ash that is generated in incinerators are destroyed or converted into non-leachable gas in the plasma gasification process. Plasma gasifiers follow same mechanism as that of other gasifiers. However, here the rate of reaction is very fast because the temperature that is supplied is very high. The chemical bonds break and result in the formation of synthesis gas, and the inorganic waste generally melt and fuse to form a slag. The energy or the internal heat that is supplied to the waste in the gasifier will depend upon the quantity of waste that you are subjecting to the gasification process. Plasma gasification is used in places where the landfill cost is very high and the demand for renewable energy is high. Now, let us discuss about the different types of gasifiers. Now, how do you select a gasifier for burning or destroying your waste? Now, gasifiers are selected on the basis of the available fuel quality, capacity and gas quality conditions. So, based on that, the gasifiers are classified into two types. One is fixed bed gasifier and the other one is fluidized bed gasifier. Usually municipal solid waste is gasified in large capacity gasifiers. Now, variable fuel feed, uniform process temperature, high turbulence, good interaction between the gases and solid and high carbon conversion make the larger gasifier more advantageous than the smaller ones. Now, we will discuss about the fixed bed gasifiers and the different types of fixed bed gasifiers. Now, fixed bed gasifiers are again a simple and easy technology to be operated. They are commonly used in small and medium scale power generation units. These gasifiers are provided with a grate to support the feed material and maintain a stationary reaction zone. Gasifiers, the fixed bed gasifiers are of two types. One is updraft and other one is downdraft gasifiers. Now, updraft gasifiers are like they are also called as counter current gasification process. In this reactor, the fuel or the waste is added from the top and the gasifying agent like your air, steam or oxygen, hydrogen, they are all injected from the bottom. That is why it is called as counter current, because they come in the feed and the air or the gasifying agent comes in the opposite direction. The syngas that is produced during the process leaves the reactor from the upper end of the gasifier. Now, within the gasifier you can see a clear zonation and the combustion occurs especially in the bottom zone of the gasifier, above which you find a zone where reduction reactions generally occur. Now, this image shows an updraft gasifier. You can see clear zonation within this gasifying unit. Now, let us look into the advantages and disadvantages of an updraft gasifier. The major advantages are they are very simple to operate. High waste burning and internal heat exchange generally results in low temperature and generally results in low temperature exit gas. Then the updraft gasifier has high equipment efficiency. Varied type of feedstock can be burnt in an updraft gasifier. The disadvantages as such are the thermal breakdown of tar is very less. They produce certain dangerous products. They might cause explosive situation. Also they require automatic moving grate. Now, the draft gasifier, it is also termed as co-current gasifier because the waste and the gasifying agent move in the same direction. Now, this is generally designed to overcome the drawbacks of updraft gasifier. The updraft gasifier faces the problem of tar entrainment in the product gas. The product gas that is produced contains a lot of tar material in that which needs to be purified. So, to avoid the disadvantage of the updraft gasifier, downdraft gasifiers are developed. The gasifying agent like your air is injected at or above the oxidation zone through a small slit or throat which is inserted in the gasifier. The waste and the air flows in the same direction as I told you earlier co-currently. Now, here the complete breakdown of tar and hydrocarbons are observed in a downdraft reactor because they move through high oxidation zones. Also, increased levels of hydrogen and light hydrocarbons are also observed in the gasifiers. The advantages of downdraft gasifiers are 1. Production of tar free gas and 2. High conversion of pyrolysis intermediates. The disadvantages are it cannot be operated for different types of feedstocks and they are not ideal for waste treatment because they require low ash fuel. The problems of flow and pressure drop is very frequent in downdraft reactors. Also, they show lower efficiency and the product gas that is produced is of low calorific value. The next type of gasifier is a fluidized bed gasifier which consists of a bed of coarse sand or limestone. Now, through this the gasifying agent is passed through and passed through in an upward direction. The gasifying agent acts like a fluidizing medium and they oxidize the cracking of tar. Through an auger or a feed chute, the waste is generally fed at the top of the gasifier. Now, the advantages like good mixing, efficient reaction, high heat transfer, good operational control and compactness of the chamber are some of the advantages of fluidized bed reactors. The fluidized bed gasifiers are generally used in places where the fuel generation capacity is 10 megawatt. Now, you can also have twin fluidized bed reactors for gasification process where the first reactor can be used to gasify the waste and the other can be used for combustion of char. Again, fluidized bed gasifiers are classified into two types, one bubbling fluidized bed reactor and the other one is circulating fluidized bed reactor. Now, in bubbling fluidized bed reactor, the shape is like cylindrical or rectangular chamber and it is operated at a temperature of 900 to 1000 degrees Celsius. The chamber shape is designed in a way so that the contact between the gas and the solid is easy and it will facilitate easy drying and size reduction through attrition. Air or steam is injected into the chamber at a high velocity to fluidize, expand, lift and bubble the bed material. Now, during such conditions what happens is like the organic waste will be vaporized by pyrolysis and then later will be combusted. Now, the second type, the circulating fluidized bed reactor, it uses a high fluidization velocity. The solids are separated and recycled back to the gasifier to improve the performance of gasifier. You do not find any clear distinction of the dense solid zone and dilute solid zone. The reactor can be used for a variety of feedstocks. On the right side you can see the image of a circulating and a bubbling fluidized bed reactor. Now, let us look into the various feedstocks that are used for the gasification process. Now, feedstocks should be chosen in such a way that they can produce energy like your wood waste such as sawdust, twigs and bark can be used. Agricultural waste like crop residue, corn stalks, spoiled food grains can be used in gasification process. Biosolids that are produced from the wastewater treatment plant can be used. Municipal solid waste and plastic waste can also be used in a gasifier. Animal waste such as stall waste, blends of various feedstocks, inorganic waste or recyclable such as glass and metals can be burnt by the gasification process. Now, the feedstock generally requires pre-processing or screening to remove the recyclables and inorganic materials, and then it can be fed into the gasifier unit. Now, shredding of feedstock can improve the efficiency of treatment of municipal solid waste, and the moisture removal also improves the efficiency of gasifier. Thus, the waste or the feedstock should be generally dried, shredded before being introduced into the gasifiers. Now, let us look into the various benefits of the gasification process. Just like other thermal treatment process, gasification reduces the requirement of landfill space. It reduces the transportation cost and it minimizes the methane emissions from landfills during decomposition of waste. It reduces the risk of contamination of water bodies. The syngas that is produced becomes a useful energy product, and the end products that are produced have a high commercial value, fertilizers and chemicals. They also enhance the existing recycling program. They also reduce the use of fossil fuels. Tar, a valuable product, is produced from the gasification process. The volume of waste is again reduced. Plastics that cannot be recycled can be burnt in a gasification process. Moreover, the low oxygen environment within the gasification unit limits the formation of dioxins and large quantities of SOx and NOx formation. Also, they require small and less expensive gas cleaning equipment due to less gas production. Lower gas volume also means a high partial pressure of contaminants in the off gas, and hence they favor complete absorption and particulate capture. Now, the disadvantages of gasification process is the tar, heavy metal, halogens and alkaline compounds are released in the gas, often cause environmental and operational problems. Tar produced during the process is high molecular weight organic gas. It possesses a potential to destroy the sulfur removal systems, ceramic filters, and they also lead to the formation of slag in the boilers and on the refractory surfaces of the gasifier. Now, the presence of alkali in the waste will affect your turbines during combustion. Likewise, the halogens will corrode the walls of the gasifying unit. At the end of this module, we have studied about what is an advanced thermal treatment process. We have discussed about the concept of pyrolysis and gasification. We have also understood the process description and the mechanism involved in pyrolysis and gasification process for waste breakdown. We also saw the characteristics and the significant application of the various products that are produced during pyrolysis and gasification process. Then we discussed about the different types of pyrolysis and gasification process, and we also studied about the different reactors that are used in pyrolysis and gasification process. Lastly, we discussed about the various merits and demerits that are associated with the pyrolysis and the gasification process. I hope you would have enjoyed this module. Thank you.